morning, students. Now I'm going to take a new topic, that is frequency modulation and demodulation, right? So in last class we discussed the what is modulation, types of modulation. In types of modulation, first one is discussed, that is amplitude modulation. Yes, now this is the second topic, that is that frequency modulation, we called as fm means frequency modulation. Yes, and their demodulation. Okay, now if you are contains if you are consider one is signal, it contains amplitude, frequency and phase. Now we are going to change the frequency of the particular signal, that is the frequency modulation. That is what frequency modulation, right? Okay, shall we go to the topic? Before that, what is frequency modulation? Yes, what is frequency modulation? So frequency modulation is the process of varying the frequency of a carrier wave in proportion to a modulating signal. Okay, what is carrier waves are? Yes, we discussed carrier wave contains high frequency, right? And okay, modulating signal, what is modulating signal, sir? Modulating signal, yes, it is nothing but voices, that is audio signals, okay, which contains information, right? Okay, so therefore fm is a process of varying the frequency of a carrier wave in proportion, yes, to a modulating signal, right? So this is what frequency modulation. At the same time, the amplitude of the carrier wave is kept constant while its frequency and the rate of change are varied by the modulating signal. Which signal? Modulating signal. So we can change only the frequency of the particular signal, their phase and the amplitude remains constant, right? So this is frequency modulation. Yes, so this is a waveform, yes, of a frequency modulated signals. Okay, see, the first one is carrier wave. First one is what? Carrier wave. So which contains what? Their amplitude. This is the amplitude and number of peaks per second, that is frequency. This is that carrier signal, right? And this is that modulating signal. This one, modulating signal. Yes, modulating signal is nothing but informations. Okay, right? And say this is that frequency modulated wave. This is what? Frequency modulated wave, right? Okay, see this session, the frequency does not changes, and up to this there is no changes in frequency, but from this to this there is a changes in frequency, right? So here the number of peaks in second is very high, therefore in this area frequency high. And if you go to this to this, there is no changes in frequency, but if we go to this to this, the frequency is very high. So here the frequency only what? Modulated. Frequency only modulated. So this is the frequency modulated wave, right? And the fourth one is phase modulated wave. I'll tell you later what is phase modulation, right? Okay, now yes, this is that simple diagram for frequency modulated signal. Yes, types. Now see, this is what? Carrier signal. Carrier signal is nothing but what? Yes, normal signal, it contains high frequency, right? And information signal, that is modulating signal. So both are combined in modulator. Which modulator? Frequency modulator, because frequency only changes now, sir, therefore frequency modulator, therefore fm modulator. Yes, both are combined together. Yes, the frequency modulated and the signal is what? Frequency modulated signal. The output of this device is nothing but frequency modulated signal, right? This is frequency modulated signal. Okay, yes, and this is for a difference between the amplitude modulated signal and frequency modulated signal. for your understanding purpose, right? Yes, this is what signal is, ordinary signal. And see, this is that amplitude modulated signal. So this, see this, the amplitude is very high, correct? But if you go to in this area, the amplitude is very less. And again, from this to this, amplitude is very high. This is amplitude modulated signal. And if you go to this area, from this to this, the peaks is, number of peaks is very high, therefore the frequency is high. But if you go to this, the frequency is less. But if you go to this area, from this to this, frequency high. That means the number of peaks per second is very high. Okay, therefore see, this is the frequency modulated waves. So this is the main difference between the amplitude modulated wave and frequency modulated wave. Okay, yes, this is another diagram for your understanding purpose. The first one is carrier signal, and another one is modulating signal, and this is that modulated signal, that is frequency modulated signal. See, this is the frequency is high, increased. Here also frequency will be increases. Okay, frequency modulation. Yes, and next is classification of frequency modulation. The classification is based on modulation index, right? In last class we discussed modulation index. The modulation index should be represented by M. Yes, so based on only we can classify the signals. So here the frequency modulated signals are classified into two types. The first one is narrow band frequency modulated, that is NBFM. See this, NBFM. Yes, and the second one is wide band frequency modulated, that is WBFM. So based on the modulation index, so M is less than 1, then the FM is said to be narrow band FM. Yes, said to be narrow band FM. In the same way, M is greater than 1. Yes, then the FM is said to be a wide band FM. Yes, that is NBFM and wide band FM. Yes, these are the types of FM, frequency modulation. And features of FM. Yes, what are the features, sir, compared to AM waves? The first one is FM system is very hi-fi, that is high fidelity, correct? And the second one is the frequency modulated signal has constant amplitude signal, and the signal to noise ratio for such system is much higher. Okay, next, the frequency spectrum of FM is same as that of AM in the case of narrow band frequency modulation. Okay, but in general the number of side bands and carrier amplitude varies corresponding to modulation index, that is for based on what? AM modulation index. Okay, so this is the special features of what? Frequency modulated signal, right? Okay, babes, this is for your understanding purpose. Again, see the wave formation clearly, then only you will understand what is modulation and frequency modulation, right? So this is what? Carrier wave. Yes, this is modulating signal, and this is frequency modulated signal, right? This frequency modulated signal. Okay, yes, so uniform AF signal modulating the carrier wave frequency. Okay, and see this, the green waves are carrier wave, and the red lines is nothing but what? Signal, information signal. Okay, that is modulating signal. Yes, now both are combined in modulator, that is FM modulator. You will get this type of frequency modulator. Here the frequency is very high, and here also the frequency will be modified. Yes, then only we will get that frequency modulated waves, right? Okay, yes, see this picture, The first one is carrier wave generated is a transmitter which contains high frequency is fit into the frequency modulator, that is FM modulator. Okay, at the same time the sound signals are is converted into audio signals with the help of microphone and is fit into the frequency modulated. Yes, so both are combined. Yes, which are combined, the carrier wave signals and yes, this electric signals, that is audio signals, are combined together and yes, the modulator gives the output is frequency modulated signal, that is FM radio signals. This signals only is fit into the antenna and transmit to the space. Okay. Yes, and now if we go to that advantages of FM, see, the first one is the amplitude of the frequency of modulated waves remains unaffected. Yes, which is one unaffected. Okay. Yes, the second one is large decrease in noise, hence increasing in is standard error ratio. Okay, that is there is decrease noise, the noise reduction will be decreases. Third one is noise may reduce by increasing deviation. Yes, increasing deviation. And the fourth one is the frequency allocation allows for a God band which reduces adjustment channel interferences. The last one is very important one, that is operate in very high frequency. Yes, that is VHF, that is very high frequency. Say for example, yes, 98.3 FM, yes, in megahertz. That is mega means very high frequency. So right, and disadvantages. See that FM has too much of advantages, besides it also has some disadvantages. The first one is FM wave cannot cover large area. Yes, okay, yes, it covers only particular distance. For example, 80 kilometers. Yes, 80 kilometers it covers this signal. And the second one is transmitting and receiving equipments for FM are complex and costly. Yes, that means we can't buy the FM frequency modulated FM station things. It is costly. Okay. And third one is a much wider channel. Yes, and typically 200 kilohertz is needed for FM. Yes, 200 kilohertz frequency signals needed for this communication. This is the main disadvantages of FM. Yes, okay. Yes, another disadvantage is same. Yes, except that this is the advantages and this one advantages and even also application. Say the first one, transmitted power remains constant. The power remains constant. Second one is FM receivers are immune to noise. And third one is good capture effect, right? And the fourth one is no mixing of signals. Okay, no mixing of signals. These are main advantages of FM, right? There is no signals or interfere to the frequency modulated signal. Okay, yes. And say the next one is the disadvantages of FM. It is used to much spectrum space. Okay, it covers huge space. That's why it's too much spectrum space, right? The second one is the bandwidth is wider. Yes. And the third one is the modulation index can be kept low to minimize the bandwidth used. Okay. And the fourth one is the reduction is modulation index reduces the noise immunity, to reduce the noise immunity. Okay. And the fifth one is used only at very high frequencies, that is VHF. Already I gave that VHF, very high frequency range. Okay, so these FM signals are used almost in FM radio broadcasting Yes, all the FMs. It start from 88 megahertz to 108 megahertz. Okay, there are so many FMs. So, for example, start from 91.1 is what is that? Radio City, and 93.5 Suryan FM, and 98.3 FM is the Radio Mechi, and 103 Rainbow, and 106.4 yes Hello FM. So these are the FMs. Is used. These FMs are used very high frequency ranges, right? Okay, and the second one is sound transmission in TV. Sound transmission in TV, that is audio signal, right? Okay, and S police wireless. For wireless communication they used FM. Okay, yes, except that other applications of frequency modulated signal, it is used as SWBFM, that is wide board that is wide band is frequency modulated in FM broadcasting system, and TV audio modulation. Yes, and that is the wide band, and second one is used as narrow band frequency modulated in very high frequency communication equipment such as portable and mobile, and is base stations. Okay, so these are that applications of FM. Yes, except that, so other applications, FM is commonly used at very high frequency radio frequency for high fidelity and broadcast of music and speech, okay, and etc. Okay, and for normal TV sound is also broadcasting using by FM. And the types of FM used in broadcast is generally wild is called FM or VFM. Is okay, and the narrow band form is used for voice communications in commercial and amateur radio settings, right? In two-way radio, and a narrow band and narrow FMs is used to conserve bandwidth. In addition, it is used to send signals into space also, right? Okay, this is the applications of what? FM, right? Now I'm going to take another modulation. That modulation is nothing but what? Yes, phase modulation. Yes, so phase modulation, right? This is the third topic in modulation. Okay, yes, shall we go to the modulation? Okay, see this, is the definition. The instantaneous amplitude of the baseband signal modifies the phase of the carrier signal, keeping the amplitude and the frequency constant. So in previous cases, in amplitude modulation, we can change only the amplitude of the signal, right? And in frequency modulation, we can change only the frequency of the wave. But in this case, the phase of the signal will be modified, yes, and their amplitude and the frequency remains constant, right? That is the frequency modulated waves, that is frequency modulation, right? Okay, yes, this is the graphical representation of phase modulation. Yes, this is message signal, okay, that is modulating signal which contains information, right? And the second one is carrier signal, which contains high frequency. Now both are combined. See that amplitude, the amplitude remains constant, and frequency also remains constant. See, the phase will be modified. See, this is phase, that means value 0 and pi, 2 pi, that means the angle will be varied. See, this is area, so this is phase will be modified, and here also phase will be modified, and here also phase will be modified, and here also phase will be modified. So this is phase modulated signal, that is PM, phase modulated signal, right? Okay, is similar to frequency modulated signal. Okay, yes, the phase modulation is a form of modulation that represents information as variations in the instantaneous phase of a carrier wave. Instantaneous phase of a carrier wave, and this signal is similar to the FM signal. I already said now. So it is so angle modulation, and the frequency modulation and the phase modulation both are known as angle modulations. Both are known as angle modulations. Okay. Yes. So this is that. Yes, for your convenient. This is which way? Modulating signal, and this is carrier wave. Sorry, this is the carrier wave, and this is that signal, modulating signal. Both are combined, the phase will be modified. See, this is the phase will be modified. Here also phase will be modified. Here also phase will be modified. Here also phase will be modified. Okay. Yes. So advantages of PM, that is advantages and disadvantages of phase modulation. Phase modulation is increased immunity to noise. Increased immunity to noise. The second one is phase modulator is used in determining the velocity of moving target by extracting Doppler informations. Doppler information. These are the main advantages of PM, right? And second is disadvantages. And phase ambiguity comes if we exciter in modulation index in the pi radiation, that is 180 degree, right? This is that first one, and that is the index, modulation index will be greater than the 180 degree. That's why it is pi radian. Okay. Second one is we need frequency multiplier to increase the phase modulation index. Without this frequency multiplier, we can't produce phase modulator signal. Okay. Yes. Applications. The frequency amplitude modulated signals used in optical communications, that is OFC. Yes, optical fiber cables. In that type of cables, we used this type of signal, that is phase modulated signal. Okay, that is optical communications. And local oscillators, and delay and add demodulators. So in delay is demodulators. By during the receiving process, we used this type of demodulators. Okay, then only we can send the phase modulated signal, right? Okay. Yes, and the next one is nonlinear effect for WSDM transmission. So what is WDM transmission, sir? This is wavelength division multiplier. Yes, or multiplexing. WDM is nothing but, see, this is the WDM is nothing but wavelength division multiplexing. Yes, transmission. Yes, based on the wavelength. Yes, the signals are transmitted. And even that multi-channel wavelength division multiplexing. Yes, this is used in optical communication systems. These are used in optical communication systems. So these are the main applications of which modulation signals, phase modulated signals. Okay. Yes, and the phase modulation is widely used for transmitting radio waves, and is an integral part of mainly digital transmissions coding schemes that unravel a wide range of technologies like Wi-Fi and GSM. We know the GSM, Global System for Communication. Yes, global system for mobile communication, and is satellite televisions. So this is the main uses of phase modulation signals. Okay. And thank you, students. If you have any doubts, we'll discuss in next videos, right? Okay. See you on next video. Thank you, students.